A sweeping wilderness of sand and sun, space and sky, stretches along the coast of southwestern Africa. It has been called a land God made in anger, an ageless land, the endless expanse. This place of wind-whipped sand and scant rain, this parched and rippled landscape, is the Namib Desert. Seemingly barren, it is unique on our planet. For these sands are home to the largest, most varied community of animal life of any dunes on Earth. Almost everything that lives here has developed in some unusual way. At dawn, the nocturnal gecko burrows deep into the sand to escape the heat of day. The backflip spider spins a web of silken sand to create its own shade. Through countless miracles of evolution, each of the desert species has adapted to the extremes. Facing the challenge of hostile elements, they have run the gauntlet of incalculable time and survived. It has been said that the name Namib means emptiness, but no one really knows. And the mute sands conceal the mysteries of its age, history, and origin. Throughout the world, the word desert has become almost synonymous with Sahara, the 3 million square miles of arid land that dominate the north of the African continent. But fringing the southwestern coast lies the relatively unknown and strangely unique strip of wilderness called the Namib, a coastal desert 1,300 miles long and 50 to 100 miles wide. Its thirsty sands have been worn and sculpted by a climate of uncompromising harshness. Here, through eons of evolutionary time, life has been tested under the most severe conditions, and surely, quietly, it has survived. For here, unlike most deserts, the dunes are often blanketed with dense fog. Gathering moisture from the fog, the rare welwitschia plant may live for 2,000 years. Throughout its long life, the welwitschia grows only a single pair of leaves. As it ages, these tough leathery leaves split and curl, fragmenting into the appearance of many. Wherever the mist settles, it leaves its legacy of moisture and life. For many creatures of the desert, the fog is their only source of moisture. The palmetto gecko drinks the water that collects on its own body. The sidewinder, too, gets moisture in this way. Life-sustaining fog rolls into the desert about 60 days a year, driven over the dunes by breezes from the sea. Warm air from the Atlantic passes over the cold Antarctic current, which runs along this coast, and the resulting drop in temperature creates the fog. But the offshore winds and chill seas that bring life to the desert have brought death to countless ships and seafarers. Their remains scatter the length of the skeleton coast. Unwary ships are claimed by the sea, swept ashore, abandoned, and reclaimed by the sands. Where shore gives way to desert, the dunes tower 500 feet in the air. They stretch for hundreds of miles along this desolate coast, sea and sand meeting in majestic confrontation. As the coast exacts its toll from those who venture on her seas, these drifting dunes have smothered man's creations on her shores. In 1908, diamonds were discovered in the sands of Coleman's Cove. The rush was on as fortune hunters converged here. Millions of carats of diamonds were mined in a frenzy of activity. By the late 1930s, the rich deposits were exhausted. There was nothing to keep man here. Now there is no sound except for the wind, no movement save that of the restless sands. Civilization was here, reaped its rewards, and moved on. Today, riches of another kind lure man to the Namib. It is the extraordinary life here that has drawn Dr. Michael Robinson from the deserts of America to Africa. Robinson is a zoologist. Reptiles are his specialty. There are some 45 species of lizards that live in the Namib. Like most reptiles, this sand lizard can only forage when its body is warm. Its feet are especially adapted to dissipate heat. To keep them from scorching on the hot sand, it lifts them alternately in the air. when it becomes too hot. For Mike Robinson, the Namib is a vast living laboratory where a whole community of creatures makes its home in the relative cool under the sand. Mike Robinson wants to know how these species compare with reptiles he has observed in other deserts. Robinson is seeking answers to some of the riddles of evolutionary relationships. He is one of a privileged group of scientists who have come to study this intricate ecosystem. A research institute was established in the heart of the Namib in 1963. Since then, more than 300 scientists from all over the globe have lived and worked here on a variety of projects. Built on the site of a deserted Hottentot village, the Namib Desert Research Institute also provides housing and laboratory facilities for a small permanent staff. The research center is accessible by a primitive dirt road that stretches across the wilderness. Mail and supplies are brought in once a week. The research director of the Institute is Dr. Mary Seeley, a PhD from the University of California. She coordinates the work of the permanent staff and visiting scientists. It was Mary Seeley's interest in wild creatures in their natural surroundings that brought her to the Namib in 1967.
Okay, Kate, these are the ones from
Here, where the laboratory and the field are only steps apart, she can study animal life under what she finds to be nearly ideal conditions.
How many have we got? 7.
Dr. Seeley's current project involves a species of beetle found only in the dunes of the Namib. In the laboratory, she and an assistant painstakingly number the tiny animals for identification. These beetles have the remarkable ability to extract moisture from trenches they build on the dunes. They are collected and weighed, and the data is recorded. The beetles are then returned to the dunes where they were found. Amazingly, even in this vast expanse, it will be possible to relocate many of them later. Subsequent weighings will indicate how much these beetles utilize fog, one part of the complex puzzle of survival in the dunes. There are more than 200 species of beetles that live here, and nowhere else on Earth. Finding its own niche in the dunes, utilizing sand, wind, and fog to its advantage, each has developed its own special behavior to master this demanding environment. These whiteback beetles remain coupled even when they are not mating, behavior yet to be explained. The mating behavior of these black beetles is quite unusual. Three males pursue a much larger female. It seems to take all three to subdue the female for the mating to be successful. In this species, there are even more males moving even faster. Swept by the force of the wind, the sands shift constantly. Abruptly, they are checked at the Quiseb River. Dry most of the time, the river may flow only once a year, nurturing the oasis of greenery that threads across this harsh landscape. The Quiseb cuts the Namib in two, and sand pours endlessly into the riverbed. The river is fed by rains that fall not here, but more than 100 miles inland. Even one day of flood a year, washing the sands toward the sea, is enough to keep the Namib forever divided. Soon after flooding, the waters disappear, the river dries. In its course, waterholes remain, providing a precious resource for the wildlife. Two scientists in residence at the research center, Ron Tilson and his wife Janet, are studying the Quiseb environment and its relationship to the wildlife and the surrounding desert.
Up in this area, Janet.
The Tilsons spend much of their time in remote areas of the river, observing and analyzing its ecology.
Oh, look. right underneath the acacias. See him right underneath that?
Steenbok, a kind of antelope, are residents here. The various animals seem to have territorial preferences, and experience has shown the Tilsons where to look for specific wildlife. Klipspringers roam the rocky slopes. Troops of baboons wander the riverbed. Ron Tilson has found that the baboons play an important role in the life of this area, for they excavate drying waterholes to tap underground sources. Thus, they provide water for many of the animals when it would not otherwise be available.
Oh, look, there they are up on the rocks there.
The Tilsons' findings may someday help to explain how creatures, large and small, have adapted to this complex wilderness. North of the river, the oasis of the Quiseb gives way to the fragmented terrain of the gravel plains. And here, too, there is life. Somehow surviving the suffocating heat, endlessly wandering the plains in search of scant rains and grasses, these animals call upon their own special adaptations to endure. This ostrich has produced her brood in the middle of a vast plain with no vegetation in sight. For 6 weeks, she has tended her eggs through the searing heat of day. On the alert for predators, she now protects her chicks on this harsh, dry landscape. Like the ostrich, the sand grouse must brood her young through the long, scorching day. To cope with the sweltering heat, she flutters her throat, creating a rapid exchange of air and thus cools her body. The chicks cannot yet fly, but must have water daily. The sand grouse have met this challenge to their survival in a most remarkable way. Each morning, the male parent flies to a distant waterhole to drink. Because predators stalk these pools, most of the sand grouse remain only a few seconds. But males with young chicks stay longer and immerse their breast feathers. These feathers are marvelously designed to hold water so that it can be carried back to the young. The search for water may take them as far as 50 miles from the nest, a round trip of 100 miles a day. His feathers heavily laden with water, the male approaches his family, and instinctively, even the newborn chicks know immediately where to drink. shadeless sand, ground temperatures may reach 170 degrees Fahrenheit. But once a week, someone from the research center must drive across the dunes. Mary Seeley enjoys these solitary journeys. For her, this infinite landscape evokes questions of how these sands were formed and when. She ponders the idea that she may be in a place where man has not been for thousands of years, where modern man may never have been before. Nine weather stations located at various sites on the desert are maintained and monitored. Day and night throughout the year, instruments measure and record such data as temperature, humidity, and wind velocity to help establish long-range weather patterns. Information gathered from the field also has immediate practical applications.
1, 7, 3, 2, 4, 1, 7, 3, 2, 4, 00, 9, 00, 00, 9, 00, 0, 2.
3 times a day, weather readings are radioed to the coast, providing statistics vital to aircraft and ship safety.
Baie dankie 279 vir je hulp. Goeienaand, oornight.
Rainfall is rare. Parts of the desert may go without rain for years. But when the rain does come, the effect is miraculous. Almost overnight, food is available, and suddenly, long-hidden creatures appear. The blue weevils haven't been seen here since the last rain. Their eggs or larvae may lie buried in the sand for years, but with the rains, they emerge. Within a few weeks, they will eat abundantly, mate, lay their eggs, and die. To discourage predators, the blue weevil has only this somewhat feeble defense. For those with no defense, there are ways of hiding in the desert. Still and stone-like, these are toad grasshoppers. They too appear only when it rains. The grassy areas are invaded by finchlarks. These nomadic birds seek out the seeds and insects that appear after the rains. They nest against tufts of grass to give shade to their young. grasses soon ripen and wither. Then the wind lifts them, tosses and distributes them over hundreds of miles across the desert. Tiny fragments of the plant material and grass seeds collect on the dune faces, away from the wind. Here the cycle of life in the Namib begins. For these humble bits of plants are food for the desert's smallest inhabitants. But even when food is plentiful, the savage struggle for life continues. The sun spider will eat at least one grasshopper a day during the brief season of plenty. Despite its name, it is not a true spider. It cannot spin silk and has no poison glands. But it is equipped with enormous jaws. First severing the head of its victim, it then saws and bites its way through the body until nothing remains. In the endless round of predation, a female wasp has found the burrow of a trapdoor spider. She will move incredible amounts of sand to get to her prey. As its first defense, the spider has dug its burrow on the slope of a dune face, so as fast as the wasp digs, the sand slides back into the hole. Often the wasp, which may have been searching for days, simply gives up. But this time, the spider is uncovered. It has powerful jaws, the wasp a sting. The outcome is by no means certain. In addition, this spider has developed a most extraordinary method of escape. It forms its legs into a circle and cartwheels down the dune. The wasp does not attempt to kill the spider, but to paralyze it with a sting so that its body can provide food for her young. She drinks fluid from the spider's jaws. This may be to refresh herself or perhaps to confirm that the spider is paralyzed. Now she buries her prey temporarily to protect it from the sun and from other predators. How she finds it again is a mystery, but she always does. The wasp will now spend nearly an hour digging her nesting burrow, which will be about 12 inches deep. When it's complete, she will bring the spider here and lay a single egg on its body. In a week, a young wasp will hatch and begin to feed on the living body of the spider. This chameleon sheds its skin about every 6 weeks. It normally lives on the ground, but climbs into a spiny bush to scrape off the wisps and tatters of its discarded outer skin. The daily search for food begins. The only snake which has adapted to life in the dunes is the sidewinding adder. This undulating motion enables it to move efficiently over the loose sand. Its hunting technique has also been perfected to suit conditions in the dunes. Unlike most other snakes, the adder's eyes are in the top of its head. The venom works quickly. After carefully realigning its jaws, the snake will use its tongue to follow the scent of the dying lizard. the ageless pattern of life and death, predator and prey, there are creatures which feed upon snakes. The snake eagle hunts on the wing. Its most common prey is the whip snake, which it can detect from a height of 1,000 feet. Nests are built in the scattered trees of the gravel plains, and both parents hunt for their chick. It would be impossible for the parent bird to contain a snake of this size in its craw. The snake is carried whole in the stomach of the parent and now goes straight into the stomach of the chick. The chick has a voracious appetite. In the next few hours, it will eat 2 or 3 large snakes. Unlike other birds of prey, it will regurgitate nothing. Scales, bones, everything is digested. On these sands, the wonders of creation and adaptation appear daily in myriad ways. In the late afternoon, a sidewinder gives birth. At night, the desert sounds with a chorus of barking geckos, males inviting females into their burrows and warning other males to stay away. Now, many of the desert's most unusual creatures can be observed. For this man, night is a favorite time on the desert. He speaks of incalculable horizons, the quiet, the experience of communing with wild things. A native of South Africa, Dr. David Hughes is both a zoologist and a photographer. He has spent months in the Namib observing and filming. David Hughes is drawn here by what he calls the joyous feeling of being close to wildlife and observing its natural behavior. He knows that many animals which avoid the heat of day completely surface now after the sun has set. The legless lizard forages for insects just below the surface of the sand. It is almost blind and probably depends upon its sense of smell to locate prey. The palmetto gecko can see particularly well at night, and the webbed feet, so effective for burrowing, help the gecko to move silently in search of its prey. But the gecko, too, must be on the alert for predators. And this is one of the most voracious of all. The golden mole. There is no animal quite like it anywhere else on Earth. It manages to live under the surface without a burrow, breathing the air trapped between the particles of sand. Blind but equipped with a well-developed sense of smell and an extraordinary ability to detect the most minute vibrations, the golden mole seems to swim like a tiny shark in a sea of sand, surfacing close to its victims and pulling them under to be devoured. It hunts beetles, spiders, termites, and the legless lizard. The gerbil is one of the few mammals in the dunes. Living in family burrows, it emerges only at night. With a tremendous appetite for insects and grasses, it flourishes when they are plentiful. A large white lady spider digs a burrow and lines its interior with her silk. Then, skillfully matting together silk and sand, she makes a trapdoor to conceal the burrow. She will lie in wait, poised upside down just under the trapdoor, responding to the slightest vibration on the surface. Not every foray is successful. A struggle might damage the white lady's burrow, so she waits for her prey to be still before dragging it under the sand. The scientists who work in the Namib have, like the wildlife, adapted to the rhythms and demands of the desert. Mary Seeley says perhaps she was pre-adapted to life here. She enjoys being alone and savors the opportunity to focus on her work. For the Namib offers challenges more rewarding than the comforts of a conventional life. She says when she first saw it, this desert was a biological system almost unexplored, full of animals that didn't even have names. Mary Seeley cannot imagine herself doing any other sort of work or living anyplace else. In the early morning hours, fog rolls in from the sea to juxtapose itself on the dryness of the desert, and the Namib turns damp and cold. The humidity reaches 100%, and mists settle on the research station. Now the dunes will be alive with creatures gathering the life-giving moisture. For Mary Seeley, the excitement of research is there on the dunes. She says that is where the discoveries are made. The desert does not give up its secrets easily. Its harsh ways require time, patience, and imagination from those who would pierce its mysteries. In every living thing, in every grain of sand, there are lessons to be learned that may help us to understand our universe. No one knows how long it has taken the creatures of the Namib to adapt to this demanding environment. It may have been tens of thousands, perhaps millions of years. Of all the adaptations, the strangest may be that of this beetle. Normally, it is active after the sun has warmed the dunes. But as fog descends on the desert, the beetle emerges from the sand and struggles to the crest of a dune. Facing into the moisture-laden breeze, it tilts its body into the air. As the droplets of water trickle down to its mouth, it drinks and survives. For those born to it, the Namib is a sheltering desert. In this sweeping wilderness, sun, fog, and sand fuse to create countless habitats, and the dunes are vibrant with life. That is the miracle and the mystery that has long lain hidden in the living sands of Namib.